Welcome to Brain Vision.
So for part A, we are going to, the angular rotation can be found, or the angular acceleration can be found from equation 10.3a. And we know that the initial angular frequency is 0. So we can say the initial angular frequency equals 0, and the final angular frequency equaling 1 revolution per minute. So we can say that alpha would be equaling the angular acceleration. This would be equaling omega times omega initial, we know to be 0, divided by t. And so this would be equal to 1 revolution per minute multiplied by 2 pi radians for every revolution, and then multiplied by 1 minute for every 60 seconds. And this would all be divided by t, 720 seconds. And so the angular acceleration is found to be 1.45 times 10 to the -4th radians per second squared. So for part B, we know that after 7 minutes, or we can say 7 minutes equaling 420 seconds, the angular speed omega would be equaling to the initial angular speed, we know to be 0, plus alpha times t. So this would be 1.45 times 10 to the -4th radians per second squared, multiplied by 420 seconds. This is giving us 6.107 times 10 to the -2nd radians per second. And so we can say that then finding the components of the acceleration of a point on the outer skin from the angular speed and the radius, we can say that for part B, the tangential acceleration would be equaling alpha times r. So this would be 1.454, we'll round at the very end, times 10 to the -4th radians per second squared, multiplied by 4.25 meters. And the tangential acceleration is found to be approximately 6.2 times 10 to the -4th meters per second squared. For the radial acceleration, this would be omega squared times r, and this is equaling 6.107 times 10 to the -2nd radians per second, quantity squared, multiplied by, again, 4.25 meters. And we find that the radial acceleration is equaling 1.6 times 10 to the -2nd meters per second squared. This would be your radial acceleration and your tangential acceleration. That is the end of the solution. Thank you for watching.